So we're going to have a look at a Leaving Cert question from physics. It's Leaving Cert 2014, and it's 12 Part B. It should take you about 10 minutes to do this question. They start off with a definition of reflection. Then they want you to draw a ray diagram. Then they want you to do a problem down here, which is going to use the mirror formula. And then they're going to ask you some kind of real-life application, what I call STS. So 10 minutes is what you should be spending on this. So let me go through the question in detail on the board. So we start off by saying, what is reflection? Well, that definition is in your notes. And I always have a key word in my head. The key word for reflection is bouncing back. So reflection is the bouncing of waves of obstacles. The obstacle could be a mirror if you're talking about light. It could be cliff face if you're talking about an echo from of sound. So all obstacles. The simple definition, 3 marks for that. This is a 12 Part B question. It's 28 marks. One of those half questions that are very popular. The next part they're asking you to do is to draw a ray diagram. Show the formation of an image in a convex mirror. Now, you know what the convex mirror looks like. The focus and the center of curvature are behind it. And I'm going to put my object anywhere in front of it. So you've practiced these quite a lot. So we're going to take 2 rays of light from the tip of the arrow. My first ray of light is always from the tip of the arrow, parallel to the principal axis. What happens to that ray of light? Well, that ray of light, as you can see, is going to bounce up. But it doesn't bounce up in any old way. It bounces up as if it came from the focus. If I put my ruler in line like that, it's going to bounce up as if it came from the focus. It'll work a line back towards the focus. That there is a virtual focus. So when you do the problem later on, F will be a negative value because the ray of light doesn't actually pass through it. It only appears to come from it. Now I need one more ray of light to form my image. My second ray of light is a ray of light towards the focus but not reaching it. Will bounce out parallel. You can use that one. Or probably the easier one to use would be the third one. A ray of light from the tip of the arrow straight at the mirror will bounce back along its own path. What do I mean by straight at the mirror? I mean in line with the center of curvature. So if I take my ruler and I put it like this, so a ray of light heading straight for the mirror, which is going towards the center of curvature, will bounce back along its own path. So you see those 2 rays of light that are getting reflected? Well, they are diverging. They're never going to meet. But they'll meet in someone's mind. If I get someone's eye to look at them, they will work them back in their mind's eye to where they meet. If you work those 2 rays of light back, where does the tip of the arrow end up? It ends up where those 2 lines intersect. The tip of the arrow will finish here. If I did all the other points will finish back down to the principal axis. I put it as a broken line to show it's a virtual image. So there's my image eye. So nothing to say. All you've got to do is draw a ray diagram, which I've done, and there's 9 marks for that. That's easy. Easy marks. Now let's move on to the problem part of it. So the problem part, go back to our notes for a minute. Problem says, person looks at our image in a shiny spherical decoration. You can see this decoration up here. That there behaves like a convex mirror. Her face is 30 centimeters from the surface. So I can say that U is equal to plus 30. The diameter of the decoration is 20 centimeters. And we've got to find the position of the image. Position of the image is V. So let me tackle that problem. So there's a picture of my decoration. The diameter is 20 centimeters. That means there's a center of curvature. The radius of curvature will be half of that. The radius, let's say, we'll call R, is 10 centimeters. And then you know that the focus is halfway between C and the surface of the mirror. There's F. So that F, that focal length, will be half again. That'll be 5 centimeters. But remember, it's a virtual focus, so you've got to put down F is equal to minus 5 centimeters. Okay, so you have to do a little bit of work to get your value of F and to put the right sign on it. She's standing. Her face is 30 centimeters from that decoration or from that convex mirror. U is always positive, so it's plus 30. And we want to find what her image distance is. Find the position of the image of her face. Well, there's 12 marks for this problem. You just go ahead and write down the formula, the mirror formula from your table book. You copy that out of your table book, you'll probably remember it anyway. But you're getting 3 marks just for writing down that formula. That's great. Just for copying out of your table book. It's like legal cogging, you're getting 3 marks. And that's all over the paper. So always write down my formula. Let me fill in the numbers. I've got 1 over U, that's 1 over 30, plus 1 over V, I'm looking for that, is equal to 1 over F, 1 over minus 5. Throw the minus out in front, so it's minus 1 over 5. So how do we solve these? Well, we get rid of the fractions. We're going to multiply right across by something that the 30, the V, and the 5 divide into. They all divide into 30V. We're going to multiply right across by 30V. We're going to multiply every term, that first term by 30V, second term by 30V, and the term on the right by 30V. And that'll get rid of all my fractions in one go for me. So 13 to 30V, V, 15 to 30V, plus 30. That's equal to minus 6V. Bring my V's to the left-hand side, so I'm going to get V plus 6V. And jump the number the other way, minus 30. 1V plus 6V is 7V, is minus 30. And therefore V, the image distance, is minus 30 over 7. Minus is important. Minus means it's a virtual image, because all images in convex mirrors are virtual. The units will be centimeters. If you want to get a better feel for that, you want to put that into your calculator and get a feel for it. So in my calculator, I get a value of about minus 4.3 centimeters. So the image is 4.3 centimeters behind the mirror. Yeah, I think I'll write that down. So the answer is 4.3 centimeters behind the mirror or the decoration, whatever you want to call it. Okay, so 12 marks for that, but remember 3 was just for writing down the formula. The last part of the question asks me, just to go back to our paper again, just have a quick look at it. The last part is, concave mirrors rather than convex mirrors are used by dentists to examine teeth. Explain why. Well, the problem with my convex mirror is when we drew the ray diagram, the kind of image you get is a diminished image. Whereas in a concave mirror, once the object is inside the focus, I will get a magnified image. So why do dentists use concave mirrors? The real reason is, obviously you don't want a diminished image of your teeth, which is already very small. The idea is to get a magnified image. So concave mirrors produce magnified images. So magnified images are produced. I always write it. Most times I try to write down a full sentence. Are produced by concave mirrors. As long as the object is inside the focus, but so they're asking me to explain why. So I'll say once the object is inside the focus. It's inside F, which is fine. So 4 marks for that. Okay, so that's the end of the question. Probably 10 minutes is all you need to do a question like that. Those kind of questions at the end of the paper, those 28-mark questions are very, very, loads of students do them. The reason they do them is because they're kind of half questions, so they can't ask you something really, really complicated.